Hi. So this is my sort of year-long project, I guess. At this point, I've procrastinated over 2 years. Uh, it's basically an ESP32 powered watch. Oh, yeah, powered watch with an e-ink screen, where the main thing of it is to to sort of just be very battery efficient while being more or less open source and easy to modify. So this is our finished prototype here. And as you can see there. And if you want to check out more on the watch, you can, I guess, take a picture of the link. Yeah. So this is basically, on the right is a sort of older prototype. Also an ESP32 watch, but designed by a different person, where it's actually rather badly power efficient. And the battery life I got out of it was maybe a week or two. Wow, as you can see on the left, the power is an average of about 46. Oh, yeah, average of 44. And going out now is the PCB prototype without a battery or vibration motor.
Okay, so these will be some of the pictures of the PCB, and there's actually a accelerometer built in, and it's used to count the steps. So this is actually a video of the testing the accelerometer, and this is with the battery attached, and you can have a size of the scale, which is quite small. And yeah, this is just the PCB. And currently it's going around also that so you guys can have a feel of how it works and how it looks. Currently, the case is a slight bit thick because it's still work in progress. So yeah, next slide. So this thing actually can pair with a phone app. It's like a bike integration kind of thing. So like some people like to have a Wistron or some sort of biking computer to have a mini map of where you are going when cycling or when you're not, wanting to look at your phone. So this actually gets a bitmap image from an app. The app draws from an API from OpenStreetMaps. So it transmits its GPS position along with speed and its heading every second or two. And yeah, it just displays it up. Yeah. And for the e-ink screens, right, we are using some screen from Good Display. It's I think 1-inch, 1.5-inch screen, and honestly, it's quite low power. And when it updates, it actually supports like rather fast partial updating with minimal artifacts. And yeah, it's about that. Yeah. And we have prototypes actually available if anyone wants to sponsor this project, because currently it's just me funding. It's me funding him to build the things and sponsoring manpower because I build boards. Yeah, it's currently the prototype is not very mass producible because the footprints chosen were actually made for hand soldering. So the pads are a little bit bigger and they don't play nice with the pick and place that I have. So yeah. So I end up having to hand solder everything after the silk screen, not the after I screen the solder paste on it. It's actually going for $80 Singapore. So yeah, it's totally hand built, and we'll be glad if you guys can support this project of ours. And whoever buys it gets free support for like software, hardware, and maybe cases, free cases printed. That's for Aden. Yeah. Yeah. And I think
Uh, yeah. And not sure how important it is, but we also have LED on the watch itself.
yeah. It blinks, yeah. Look. It makes colors. Yeah. And yeah, for the for the other smartwatch going around, I can actually pair up with my phone right now, and you guys can have a feel of the app which sends bitmap images over to the watch, and you guys can have a feel of the UI. Yeah.
Can you talk a bit about the software stack?
The software stack is made with a bit of I think was it Rust?
It's
Yeah.
a bit of Rust.
It's getting rusty, yeah. It's mainly C and C++, and the Rust mainly runs on the LP core. There's a low power core on this ESP32C6, and it draws like I think about 40 odd microamps. So yeah, the software is outsourced to another guy, and yeah, the guy's in Poland, so I'm not really, yeah. I'm doing hardware, so it's not really something that I'm too familiar in the software. Yeah. Okay. What else? Yes, there's a vibration motor also built in, and I guess it can be considered haptic, but we are trying to optimize because currently it's a rotary kind of like motor with a mass on it. So I'm trying to look into different kinds of feedback mechanisms, especially maybe Z-axis kind of vibration motors or even buzzers, because currently it is transistor driven, so it will accept a bunch of outputs. Even it can even output a PWM signal to drive a speaker. And I've done that, and it sounds not bad. Yeah, it can make. It supports both Wi-Fi and Bluetooth. Bluetooth mainly for the mini-map application, and Wi-Fi is for the weather, time, and even Bitcoin wallet sync. You can see amount of money you have on your wrist. I don't know why that is a thing, but yes, someone requested it. Yeah.
Bluetooth headphones yet?
Not yet. There's actually not enough memory on this thing to play songs. I would look into it. I mean, most SD cards run on like SPI, so yeah, probably can get a. Yeah, might look into micro SD, but there's not enough space on the PCB, so something will have to be sacrificed. Yeah. Right. So I'll pair it with my phone now, and you guys can have a look of how it works.
Consider the design to use for other things than the watch.
The microphone tak laku. The questions are not getting like
Yeah, so that's the